that's what life was like in Sydney before I left. Okay, so let's think now about using our electrical energy. And we think about, we can call it consumption. We're not actually eating it, but we are using it when we turn on our switches in our houses. Now, the way that you have to, I guess, know a few background things. And our power points are 240 volts, aren't they? If we buy appliances, so I don't know if any of you have, you might have a 2 kilowatt, you might say it's a 2 kilowatt heat pump, or it could be a 1200 watt microwave oven. It could be, let's look at the bigger thing, 6 kilowatt central heating. So what this is doing is giving us an idea of how greedy, if you like, these appliances are when you plug them in and turn them on. And you wouldn't want to have too many of these on the same run of wire through your house. Otherwise, it's not safe, because if we're thinking about the rate of work, and we're thinking about this as really, we need our electrons moving for us to get this energy out of our electrical energy, then we're going to need a lot. 6 kilowatts is a fair bit. Kilowatts here, 1,000 watts. Kilo is on your formula sheets, but you're probably familiar with it for kilogram, but you may not have thought of it too much in terms of other things. So, we've got all of these appliances in our house, and some of them might be turned on and some of them are turned off at different times of the day. But if you go out and have a look in your meter box out on the wall of your house, you'll be able to see there's a dial. Oh, I've got, I think, hydro changing the meters over around the state, but we probably all still have a dial. I have 2 meters. I have a general electricity and a hot water meter. But it turns really slowly, and you can see if you are consuming electricity all the time. And if you go out there and you flick that switch, then you'll annoy everybody inside, because all of a sudden they won't have any electricity, and they'll notice immediately. It's even probably worse than if there's a problem with the internet, because if there's a problem with the internet, everyone in my house comes out to see what's going on, which the world is ending. And so we're going to be buying the electricity that we use in what's called kilowatt hours. So if this is a kilowatt, then a kilowatt hour is then how much we're using in an hour. How many kilowatts in an hour. And we can convert between joules and kilowatt hours with this little calculation here. So 1 kilowatt hour, that's 1,000 watts for 1 hour. Now, if we remember our relationship, therefore, our watts are in joules and our time is in seconds still, then this is 1,000 joules per second for 1 hour. Okay, so we had it per 1,000 joules a second, but it's 1 hour. So how many seconds are in an hour? 60. There's 60 minutes in an hour, and there's 60 seconds in a minute. So to find out how many joules this is in total, we're going to need to multiply 1,000 by 3,600 gives us 3.6 times 10 to the 6 joules. That's how much energy is in a kilowatt hour. So I could have written it out as 3,600,000 joules as well. Make sense? So this is our relationship between kilowatt hours and joules. Now, it says in here, yes, the cost per kilowatt hour in Tasmania varies according to what it is being used for. That's not a very well constructed sentence, but we won't worry about that. Hot water heaters are charged at a lower rate than the general power. That's why I have 2 meters. I have general power and I have a hot water one. And if you have central heating, it's allowed to be wired into your hot water meter as well, and it's charged at a lower rate. But the general cost per power is about 28 cents per kilowatt hour. 28 cents per kilowatt hour. Okay, so a 1 kilowatt appliance turned on for 1 hour uses 1 kilowatt hour of energy, and that would cost 28 cents, wouldn't it? Okay, we had our 1 kilowatt appliance on for an hour. If we had a 2 kilowatt appliance, so 2 kilowatt, sorry, it's 2.4 kilowatt, and we have it on for 2 hours, then it's going to use 4.8 kilowatt hours. And then if I want to find out how much that is going to cost me, I would then have to multiply that by 28 to find out how many cents it is. Now, probably one of the most common errors students make with these calculations is getting your dollars and cents mixed up. Okay, so 4.8 times 28 is going to be $1.34. Because it tells me, if the answer was 134, but that's cents. We should always look at our units and our answer and make sure our answer is a reasonable. It's more reasonable for me to express it as dollars and cents than it is, I think, to express it as just cents. But you need to make sure you know the difference. You can't say it was $134, for example. And because we're using some big numbers, sometimes we end up with crazy wrong answers. So please double check your answer. Does this make sense? I've seen, remember, you know, like marking, and there was a question about, on an exam, about how much it costs to charge your phone. So, you know, you've got a mobile phone, you've plugged it in for, say, 4 hours to charge it. How much did it cost you? And there were people's answers that were in the millions of dollars. Well, that just doesn't make sense, does it? So you have to think to yourself, does this make sense? And if it doesn't, then maybe have another look at your calculation. So here we've got an example. And it mightn't hurt if you go home and ask it to see the last hydro bill. how much will it cost to run a 200 watt? So we've got 200 watts. That's power. And it is a 76 centimetre TV. In actual fact, the fact that it's a 76 centimetre TV makes no difference to answering the question. It could be anything. So just gloss over what it is that they're talking about. Time. 6 hours a night over a 1 week period. So we have 6 hours for 1 week. Well, that's going to be 7 times 6, isn't it? To tell me how many hours that is. But then I have to multiply that by 60 for the minutes and 60 for the seconds, because I need to get my time in seconds. Oh, sorry, that's wrong. I just want hours. It's kilowatt hours on that was just that's so that's going to be 42 hours. Sorry, I was getting my metaphors mixed up. And the cost is 28 cents per kilowatt hour. So I've changed my time into hours, but I also need to change my power into kilowatts. To go from watts from kilowatts, I'll need to divide by 1,000. Because there's 1,000 watts in the kilowatt. Now I can just multiply 0.2 times 42. And then they've multiplied that by, in the answers, they've multiplied it by 28 cents. So our answer is then going to be in cents, 235.2 cents, gives us $2.35. Alright, so yeah, these questions, I think, for some reason, I think it's lack of familiarity with paying bills is what makes these questions more challenging for you. Because when you pay the bills and you see these sorts of things all the time, it becomes more familiar. All right, so keep going with those questions then.